So welcome back all the students. So we are back here again with one more new video. In today's period we will be discussing about the representation of the configuration of the molecules. Then we will be representing regarding the chemical properties. In the chemical properties we'll be seeing the nucleophilic substitution reaction, and then we will be seeing the addition reaction and the elimination reaction, right? So let's begin our period. In today's period, the first topic will be representation of configuration of molecules, right? So the basics of this you had already learned in your 11th standard, that how to represent the particular molecule. There are different ways of representation of the molecules, right? So basically today I'm going to tell you the two ways of representation of the molecules, right? So it can be represented in the two ways, that is the Fischer's projection formula. Fischer's projection formula. And the second one representation is wedge dash formula, right? It is also mentioned in your textbook, Fischer's projection formula and wedge dash formula. These are the two ways of representation of the configuration of the molecules. Now let's quickly learn this Fischer's projection formula. Okay, now the question comes, why do we learn the Fischer's projection formula? Why? The question is why? Why? Because the molecules which are around us are all three-dimensional molecules, right? They are all three-dimension in a nature. So when we represent this three-dimensional molecules on the paper, they become two-dimensional, right? So representation on the paper is always going to be difficult. That is why to show 3D molecules properly on the paper, we use Fischer's projection formula, right? So in the Fischer's projection formula, we can show the three-dimensional structure on the paper in a two-dimensional way. That is why we use the Fischer's projection formula. So you all have to remember this, why we use the Fischer's projection formula. Okay, now let's quickly see how do we represent this particular Fischer's projection formula. See, it is very easy. You have to just draw a cross line, or we can also call this as the cross formula, right? The other name for the Fischer's projection formula is cross formula. See, it is like a plus sign. One is the horizontal line, and one is the vertical line, right? See, my dear students, in the Fischer's projection formula, this horizontal line and vertical line, both of them have some or the other kind of a significance. Now what is the significance of this horizontal line and the vertical line? See, the horizontal line represents that the molecule is above the plane, right? And what is the vertical line? Vertical line represent that the molecule is below the plane, right? So here I can take one example. I will show you one example. For example, this is carbon, this is Cl, this is hydrogen, this is iodine, and this is bromine, right? This is a chiral carbon. You all know what is a chiral carbon, containing 4 different groups, is called as the chiral carbon. Now in this particular chiral carbon, you can see it is a cross formula. One is containing the vertical line, one is containing the horizontal line, right? So here we can see that the one which is on the horizontal, they are called as the above the plane, right? Now what does the word above the plane means? See, above the plane means they are coming close to us, and below the plane means they are going away from us, right? For example, here I can show you how horizontal is represented. See, the horizontal is represented something like this. See, are you all able to see? right? So this is the horizontal way of representation. Now this is nothing but it is showing the above the plane, which is coming close to us, right? That is called as the particular horizontal line representation, right? Then we can also see the vertical line representation. In the vertical line representation, it is denoted by the dash, or we can say it is denoted by the dot, right? So here in this case, we can see that this is nothing but below the plane. This is going away from us, is called as the below the plane or the vertical line representation. So I hope, my dear students, you have understood both the presentation, how the horizontal line is represented and how the vertical line is represented. This horizontal line is also represented by the wedge. This is also called as the wedge, right? And this is also called as the wedge. See, or we also call them as the wedge representation, right? And this is the dotted representation, right? One is above the plane, one is below the plane. Okay, now let's see the other example. Okay, now let's look at the wedge and dash formula. You can note down wedge and dash formula, right? Now in this particular formula, see, this is the carbon atom. I'll show you the wedge and dash formula. This is iodine, this is chlorine, this is the wedge. See, this is wedge, a bromine atom, and this is the dot or dash, you can say, right? So this is the representation of the wedge and dash formula. This is the wedge, and this is the dash, right? So here in this case, iodine and chlorine, they are in the plane of paper, right? Consider this is a paper, they are lying in the plane of the paper, right? Then talking about the hydrogen is below the plane. What we had seen in the Fischer's formula, dotted wala, dash wala क्या होता है? Below the plane होता है. Wedge वाला क्या होता है? Wedge वाला जो होता है वो above the plane होता है. Above the plane, right? Then what is below the plane? Below the plane means going away from us. Is called as the below the plane. What is the above the plane? Coming close to us is called as the particular above the plane, right? So I hope that you have understood the representation of the configuration of the molecule. That can be done by two ways: Fischer's projection formula or the wedge and dash formula. Okay, so my dear students, we will move forward. We'll see the next concept, that is the chemical properties. You can note it down, chemical properties of haloalkanes, right? So you know what is the haloalkanes. We had learned during the introduction of the chapter haloalkanes, haloalkenes, haloalkynes. Haloalkanes is also called as the alkyl halides. Don't forget this, the other name for the haloalkanes, right? So here in this case, haloalkanes are represented by the Rx, right? Where R stands for alkyl group and X stands for halogen group, right? So this halogen is X equals to fluorine, chlorine, bromine and iodine, right? So you have to always remember this. One will be highly positive and one will be highly negative. That means there is the particular bond between the Rx is nothing but the highly polar bond, where the R will be containing a positive charge and X will be containing the negative charge, because X is a highly electronegative in a nature. Okay, now before going for the chemical properties, we have to see the two things. that how exactly this particular halogens are reacting. There are two ways by which we can say that how they react. That is the nature of CX bond, by the nature of CX bond, and the second one is reactivity of halogens. Right? So their chemical properties are depending on the two factors, nature of CX bond and the reactivity of the halogen atoms. Now let's quickly look at the nature of CX bond. In the nature of CX bond, I had already told you CX is nothing but the R only. Here R means alkyl group. ये alkyl group का कार्बन है, इसलिए CX भी बोल सकते हैं, RX भी बोल सकते हैं. Anyways, you can spell it out. So here I am taking it as CX. So in this particular CX bond, we all know that the carbon contains the positive charge, halogen contains the negative charge. Halogen being highly electronegative, it will pull the electron towards itself, right? So here in this case, what happens now, this particular negative will be attacked by the positive reagent, and this particular positive is attacked by the negative reagent, right? This negative reagent is nothing but called as the nucleophile, and positive reagent is called as the electrophile, right? Further we will see what is the electrophile and the nucleophile, but you have to understand that positive will always have the attraction for the negative and negative will have the attraction for the positive, right? The positive reagent is called as the electrophile, negative reagent will be called as the nucleophile, right? So you all have to remember this particular concept. Okay, now let's quickly discuss about the reactivity of the halogens. Reactivity of the halogens, this is very important. I had already told you when I was telling you about the trends, right? Reactivity trend. So what is the reactivity trend? The reactivity trend, we know that the Ri is the most reactive and Rf is the less reactive. Now why it happens so? So in order to understand this, we have to understand the bond length, right? So what is the bond length in this case? See, we all know that the Ri has the highest bond length, then RBr, then RCl, and then RF, right? So here one thing you all need to remember, higher the bond length, lower will be the bond dissociation enthalpy. You can note it down. Higher the bond length, lower will be bond dissociation enthalpy. Or you can also call it as energy. Bond dissociation का मीनिंग क्या होता है? ब्रेक होना, राइट? सो इसमें से सबसे पहला बॉन्ड कौन सा ब्रेक होगा? जो सबसे बड़ा बॉन्ड है. हायर द बॉन्ड लेंथ, लोअर विल बी द बॉन्ड डिसोसिएशन एनर्जी. दैट मीन्स जिसका सबसे बड़ा बॉन्ड लेंथ है वो सबसे पहले डिसोसिएट होगा. कैसे डिसोसिएट होगा? R प्लस I माइनस. अगर ये सबसे पहले डिसोसिएट होता है, जल्दी डिसोसिएट होता है, तो ये सबसे जल्दी रिएक्ट करेगा, राइट? दैट मीन्स this Ri will be highly reactive in a nature. Then RBr, then RCl, and then RF. So you all can note down the reactivity order. That is, the Ri is most reactive, then RBr, and RBr is most reactive than the RCl, and RCl is more reactive than the RF. So now here in this case we can say Ri is the most reactive, RF is the least reactive, right? So my dear students, before going for the chemical property, you should know the basics. What are the factors of the reactivity? Which is highly reactive and which is less reactive, right? And which particular what are the particular substrate and what are the particular reagents which are used in the reaction, right? So this is what is the concept of the chemical properties of the haloalkanes. Okay, so my dear students, there are basically three types of reactions shown by the alkyl halides. So what are those three kinds of reactions? These are very, very important reaction, my dear students. You all need to focus properly on these reactions for your board exam. Now the number one reaction, nucleophilic substitution reaction. Nucleophilic substitution reaction. Number two, elimination reaction. Number three will be addition reaction. Right? So my dear students, these are the three most important reaction as far as your board exam is concerned. Out of this three, the most important reaction is nucleophilic substitution reaction. Right? So my dear students, when we come for the next period, I'll be telling you in detail what is the nucleophilic substitution reaction and what are the types of the nucleophilic substitution reaction. Till then, you stay tuned and you watch the video again and again so that the concept of the particular chemical properties will be clear to all of you. Thank you very much.